In this video, we are going to combine different linear systems practice and linear inequalities practice into this major concept called linear programming. Now, linear programming is a method to achieve the best outcome in a mathematical model whose requirements are represented by linear relationships. So what that means is, given a lot of information on maximizing profit or minimizing cost, are typically our two objectives, we have some constraints that are represented as linear models. So let's look at an example of that. So you are an assistant manager of TechTown Technologies. The manager asks you to do a cost analysis to determine what stereo systems the store should order. Next month, you will order two types of stereo systems: home theater audio system and shelf system. As assistant manager, you must determine how many of each brand to purchase to maximize profit. Alright, first thing to note here, we are trying to maximize profit. In these types of problems, we want to make sure you're either if you're trying to find the maximum of something or a minimum. Alright, so you're going to find the greatest number or the smallest number. In this case, it's the greatest because we're maximizing. You expect to sell at least 5, but no more than 10 of the shelf system units. Also, you expect your sales of the home theater system will not exceed 12. The number of shelf systems cannot exceed the number of home theater audio systems. Each home theater audio system produces a $70 profit for the store, while each shelf system produces $30. A lot of information to take in, but we're going to break it down. First off, we want to look at our objective, and we said before is to maximize. But what are we trying to maximize? We're trying to maximize profit. Well, in order to write a model to maximize profit, I need to identify decision variables. And so in this situation, the things that are changing are the amount of home theater audio systems sold and the shelf systems sold. And so I'm going to represent X and Y as the home theater audio system and then Y as the shelf system. All right, so now let's write an objective function here. So like we said, our objective is once again to maximize profit. So I need to write a model or a function that gives me a profit. And so looking back into this second paragraph, home theater audio system produces a $70 profit. So for each X or each of these systems, I get $70 profit. For each Y or the shelf system, I get $30 of profit. We're going to once we write this objective function, we're going to come back to it. Alright, so now we need to take all of these limitations, or what we call constraints, and organize them. Okay, so our first thing here is we expect to sell at least 5, but no more than 10 shelf systems. So shelf system is represented as Y. So that's saying that Y is going to be greater than or equal to 5, but less than or equal to 10, because we are between 5 and 10. We also expect the home theater system will not exceed 12. So in this situation, X for our home theater system is going to be less than or equal to 12, because it cannot exceed. The number of shelf systems cannot exceed the number of home theater systems. So what that's saying is home theater must be greater than or equal to my shelf system. And that covers my objectives or my constraints here. Alright, so now what we're going to do is we are going to take these constraints and graph them. Alright, so we have to go back to that graphing inequalities practice. I'm going to graph each of these constraints. So first off, the constraint Y is less than or equal to 5 and less than or equal to 10. It can actually be broken down into 2 lines. So I can cover up 10 and just look at Y being greater than or equal to 5. So go to your Y-axis, and I'm going to go to 5. And since it's all of these are greater than, equal to, less than, equal to, I'm going to use solid lines for everything. And I'm going to go to 10 and graph a line. since it's just a y equals line, there's no x, there's no rate of change, we're going to have just a horizontal line. I'm going to wait to shade until the very end. Alright, so now let's graph our constraint x less than or equal to 12. So go to 12 on the x-axis and draw a line. And then go to y has to be less than or equal to x. So in this situation, this can be represented as the equation y equals x, which we know is going to be a line that cuts the origin. And if you really are struggling with graphing when you have a rate of change like x, then just know my intercept here is 0, so I start at 0, and my slope is 1, so I'm going to go up 1 over 1 each time, which makes this. So now let's go ahead and shade in these constraints. So I know that y is between 5 and 10, so it's between my two horizontal lines. I also know that x is going to be less than 12, so I can shade on the other side of my x, my vertical line here. And then I know that x is greater than or equal to y. So x is greater than or equal, or in this situation, y is less than or equal to x. Either way you look at it, looking at this constraint here, I'm going to shade below it, given my less than equal to. And now I'm going to go back in my pen and I'm going to highlight the region that is covered by all of what I shaded, which in this situation is this trapezoidal region here. Alright, this is called my feasible region. And I want you to notice there are specific points that bound this region that we call corner points. Now, these corner points I'm going to write into a table. So the first being 3 and 5. 10 and 10. 12 and 5. And 12 and 10. And then what I'm going to do is I'm going to find the profit. So what these coordinates give us are, they give us a product mix, or a mix of our two variables. So in this situation it's saying 3 of the home theater, 5 of the shelf system. But I want to find the actual profit that goes with each of these corner points. And so that's where my objective function from the first page comes into play. This objective function is what I'm going to use to find the profit. And so instead of writing x and y, I'm going to write these different points that I have here. So the profit is equal to 70 times x plus 30 times y and I'm going to do this for each of them. And I'm going to attempt not to mess up. And so what I'm going to do is I'm going to go grab a calculator and we're going to go ahead and get this done. If you don't have a TI-84, that's fine. You'll notice I'm going to use my phone to do this. Alright, so 70 times 3 plus 30 times 5 gives me a profit of $360. 70 times 100 plus the 300 gives me a profit of $1,000. 70 times 12, which is 840, plus this gives me a profit of $990, and then this final one gives me a profit of $1,140. So once again, I'm trying to maximize my profit. So the corner point that gives me the highest amount of profit is this corner point 1210. And so what that's telling me is I need to buy 12 home theater systems or home theater audio systems and 10 shelf systems for a max profit of $1,140. Thanks for watching.